Welcome to Biology My Passion. I am Soumya Harikrishna. Today we are discussing a few numericals from physics across the chapters. It's not chapter wise. These are from some previous year's papers. So here first question goes like this. Calculate the refractive index of the material of glass slab given that speed of light through the glass slab is 2 into 10 to the power of 8 meter per second and in air it is 3 into 10 to the power of 8 meter per second. So what all things are given and what is to be found out? We are supposed to find out refractive index of glass. So we can write Ng, refractive index of glass Ng we have to find out. And we know the velocity through the medium, that is V is equal to 2 into 10 to the power of 8 meter per second. And that through air or vacuum it is called as C. So it is 3 into 10 to the power of 8 meter per second. This value you have to know by heart. Sometimes will give in the question itself. So to find out refractive index, we have the formula N is equal to C upon V. So this refractive index is actually absolute refractive index because one of the media is air or vacuum. So if you do this 10 to the power of 8 meter per second and 2 into 10 to the power of 8 meter per second. If you cancel this, you will get 1.5. This all will get cancelled. So our answer would be 1.5. Is there any unit? No, there is no unit because refractive index is a ratio. A real image itself means what? Inverted, right? So 1/5 of the size of the object is formed at a distance of 18 centimeter from a mirror. What is the nature of the mirror? Calculate its focal length. So let's go through it again and see what all things are given. A real image, that gives some indication. 1/5 of the size of the object. So magnification is 1/5. But it is a real image, so we have to put a minus value for that. So magnification is minus 1/5 at a distance of 18 centimeter from a mirror it is forming. So image distance V is equal to 18 centimeter. So we know that it is a real image. Real images are formed always on the left side of the mirror. So it is minus 18 centimeter in case of mirror. What is the nature of the mirror? So here we know that first of all it is diminished. So we know that diminished can be convex or concave mirror, but since it is a real image we know that it can be a concave mirror only because concave mirror only can produce real image. Because convex mirror always produces virtual and erect images even though it is diminished. Then calculate its focal length. So in order to find out the focal length, we have a formula, mirror formula, 1/f is equal to 1/v plus 1/u. But here do we know u? No, u is also not given, only m is given. So we have a formula using v and u, that is m is equal to minus v upon u. That is magnification, minus 1/5 if I substitute is equal to minus 18 upon u. So we can say that minus u is equal to 5 into 18, that will be 19. So is equal to minus 90 centimeter. So we got u. Now we can substitute this in the mirror formula. 1/f is equal to 1/v plus 1/u. So 1 minus 18 plus 1 minus 90. So what is the LCM? LCM would be 90. 18 5 times, so minus 5 plus 90 1 time minus 1. So minus 6/90 is 1/f. Therefore f will be 90 by minus 6. It will go 15 times. So minus 15 centimeter. If it is minus 15 centimeter, because it is a concave lens, right? Focal length should be minus. Next question. A student uses a lens of focal length 40 centimeter and another of minus 20 centimeter. Write the nature and power of each lens. So first lens is having focal length 40. F1 we can write 40 centimeter. So if the focal length is positive, then it is a convex lens. The other one F2 we can take, it is minus 20 centimeter. So what will be the nature? It is a concave lens. Concave lens, mirror or lens, concave will be negative value, convex will be positive for focal length. Okay, so now we have to see the power. Power I will write P1, which is actually the reciprocal of the focal length. but the focal length has to be in meter. 40 centimeter in meter means what? 40 by 100, so 0.4 meter. The same way 20 centimeter will be 20 by 100, that is 0.2 meters. So 1 by f, how will we find out? 1 by 0.4. So if I want to remove this one decimal, I can multiply by 10 on both numerator and denominator. I will get 10 by 4, which will be 2.5 diopter. So the power of the first lens is 2.5 diopter. Whereas the second lens we can find out P2 is equal to 1 by f, again 1 by 0.2, multiplying by 10 to remove the decimal, 10 by 2. So what is the power? 5 diopter. So the first lens has a power of 2.5 diopter. Second one, yeah, it is minus, so it is minus 5 diopter because it is concave lens. Next question is from electricity. In the circuit given below, the resistors R1, R2 and R3 have values 10 ohm, 20 ohm and 30 ohm respectively, which have been connected to a battery of 12 volts. So the volt available here is 12 volt from the battery. And what is the current of arrangement here? They are arranged in parallel connection. Okay, so let's see what is the question. Calculate the current through each resistor, because we know that when they are connected in parallel, potential difference across the ends will be the same, but for each resistance, but its current will be the sum of the individual currents. And we have to find out the total resistance in the circuit and the total current in the circuit also. First we have to find out the current through each resistor. So according to Ohm's law, we know that I is equal to V by R. So we can take the first one as I1. I1 is equal to V by R1. V is constant here. 12 volt is available for all. So 12 by first is 10. So 1.2 ohm. Then I2 will be V by R2 is equal to 12 by 20 it will be, right? So it will be 0.6 ohm. I3 is equal to V by R3 12 by 30, that is 6 by 15, 0.4 ohm. Okay, so each resistor we found out I1, I2 and I3. Now the total resistance in the circuit we have to find out. Since it is parallel, the total resistance, effective resistance will be 1 by R1 plus 1 by R2 plus 1 by R3. That is equivalent to 1 by 10 plus 1 by 20 plus 1 by 30. So if you take the LCM, it is 60. So 6 plus 3 plus 2. 11 by 60. Therefore, RP will be 60 by 11. Okay, so you will get the decimal place 5.45 ohm. That is the total circuit resistance. Now the total current in the circuit we have to find out. Total current, already we have found the individual current. We can just add. I will be I1 plus I2 plus I3. Right. 1.2 plus 0.6 plus 0.4. So 2.2 ampere. Now find the minimum resistance that can be made using 4 resistors each of 20 ohm. So here is a word minimum. So we know that if you connect in series, you will get maximum. Whereas if you connect in parallel only, you will be getting minimum. So if you are connecting 4 resistors, that is R1, R2, R3, if you say 1 by RP will be 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. But here all are 20 ohm. So you know that 4 by R. So what is RP? R by 4. What is R here? 20. 20 by 4. So what is the answer? 5 ohm. So this is a case-based question. A student focused the image of a candle flame on a white screen by placing the flame at various distances from a convex lens. He noted his observations as follows. You can see distance of flame from the lens is 60, distance of the screen from the lens is 20. So that is object distance and image distance. In each case, here it is 40, here it is 24, here it is 30, it is 30, it is 24, 40, 15, 70. So what is given here? It is just showed that he is keeping at different distances. Okay. From the above table, find the focal length of lens without using lens formula. So how can you find out? Because no other details are given, only this table is given. So here we have a clue for it. That is, in this we can see that the object distance and image distance are same. So in the case of a lens, when is the object distance and image distance same? When it is at a 2f, right? Whereas in the case of mirror, it is at a center of curvature. So here, since it is both 30, so we can say that 2f is equal to 30. So what is f? F will be 30 by 2, that is 15 centimeter will be the focal length of the lens. Then which set of observation is incorrect? Justify your answer. So from this we are getting an idea of about the distance, because this 15 centimeter is the focal length. So in this, if you see 15 centimeter focal length, so if you are keeping at 15 centimeter at the focus, what should be the image distance? It should be at a infinity, but here it is given 70 centimeter. So this could be the wrong observation. So fifth observation is wrong, as the object is on the focus, so the image should form at a infinity. Next question, out of the 5 incident rays shown in the following diagram, find any 2 incident rays that are obeying the laws of refraction of light and may be used for locating the positions of the image formed by a convex lens. Usually we use 2 rays only, right? Use these 2 rays in finding the position, size and nature of the image formed when an object is placed between f1 and 2f1 of a convex lens. Look at the diagram. This is ray 1. You know that ray 1 is not following the law of refraction, whereas ray 2 is coming parallel to the principal axis, and after refraction it is passing through the focus. So 2 is correct. 3 passes through the optical center without deviation. So 3 is also correct. Actually, if we can consider, they have asked for only 2 incident rays, but if you see, 4th is also correct, because 4th is passing through the focus. So after refraction, how should it go? Parallel to the principal axis. So that is also following the rule. So we have to now use any 2 of this to find out the position, size and image form when an object is placed between f1 and 2f1 of a convex lens. Suppose this is a convex lens, our object is between f1 and f1. So between 2f1 and f1. So the first line coming parallel to the principal axis. After refraction, it will pass through the focus. The second one directly coming through the center of optical center without any deviation. So we are getting our image beyond 2f2. So whenever you are drawing rays, you have to show the arrow mark, the direction of the ray. So this is the image, here is the object. The magnification of an image formed by a lens is m is equal to -1. I'll come to the explanation after reading the question. If the distance of image from the optical center of the lens is 25 centimeter, okay. Where is the object placed? Draw a labeled diagram to show the image formation in this case. So here we have a clue. Magnification is given as -1. So children, whenever you are taking magnification, you have to take this value separate, this digit separate. So the digit shows the size. 1 means object size is equal to image size, right? Whereas this minus or plus shows real and inverted or virtual and erect. So here it is minus, so real and inverted. But here we know that the magnification is 1 means what? The same size of the object. So we know that object is kept at 25 centimeter. So 2f is equal to 25 centimeter we can take. So where will the image be formed? Image is at object is at 2f1, image should be at 2f2. This is the ray diagram for this object distance is 2f1, so image is at 2f2 and the size is equal. Now the next question, what is the maximum resistance which can be made using 5 resistors each of 1 by 5 ohm? So maximum, if asked, we have to go for series connection. So usually if you connect in series you will get maximum. So 5 resistors we have, each one 1 by 5. So 1 by 5 plus 1 by 5 plus 1 by 5 plus 1 by 5 plus 1 by 5. So you just have to calculate. Total will be 5 upon 5. So what is the answer? 1 ohm. Next question, define optical center of a spherical lens. Optical center is the central point of a lens through which a light ray passes without any deviation. You are given a convex lens of focal length 30 cm. So f is equal to 30 cm. It's plus because it is convex. Where would you place an object to get a real inverted and highly enlarged image of the object? Draw a ray diagram showing the image formation. To get an object real inverted and highly enlarged image, we have to keep the object at the focus. Then we have to show the ray diagram. Here you can see the ray diagram. When we keep at the focus, you can see that it is a highly enlarged image, real and inverted. A concave lens has a focal length of 20 cm. So next is a f is equal to 20 cm, but the lens is concave, so focal length should be negative. Okay. At what distance should an object be placed? So we have to find out u, so that it forms an image 15 cm away from the lens. So v is equal to 15 cm. Now we can use the mirror lens formula. 1 by f is equal to 1 by v minus 1 by u. Therefore, we have to find out u. So 1 by u is equal to 1 by v minus 1 by f. Here v is 1 by minus 15 minus 1 by minus 20. So 1 by minus 15 plus 1 by 20. So the LCM, if you take, it is 60 minus 3. Sorry, minus 4 plus 3. So 1 by u is equal to minus 1 by 60. Therefore u is equal to minus 60 centimeter. You have to get u minus because u is invariably negative. Next question is from electricity. For the combination of resistors shown in the following figure, find the equivalent resistance between M and N. So these are the 2 points M and N. We have to find the equivalent resistance. So it's a very simple one. We know that R1, R2 are in series. They are connected in series to these two, R3 and R4, which are connected in parallel. So first we will solve R3 and R4. So here, since the values are not given, we can write that R1 plus R2 plus 1 by R3 plus 1 by R4, right? These two, if you solve, what will you get? R1 plus R2. So the next question, how many 132 ohm resistors in parallel are required to carry 5 ampere current on a 200 volt line? So here each resistor is having a resistance of 132 ohm, but we do not know how many of them are required. Okay, then current we need is 5 ampere current, and potential difference available is 220 volt. So we have to find out how many resistors are required. So in order to find out R, in this case we know that since they are connected in parallel, 1 by Rp parallel, if I take, it will be 1 by R1 plus 1 by R2 plus 1 by R3. So it will go on till X, because we do not know till where. So X is the last number if we say. So if I substitute 1 by 132 plus 1 by 132 plus 1 by 132 like that till X. So I can write this as X by 132. Therefore what will be Rp? It will be reciprocal, 132 divided by X. We have to find out according to Ohm's law, V is equal to IR, right? So we know 220 volt is equal to what is I? 5 ampere into what is R? 132 upon X. So what will be X? 5 into 132 upon 220. So we can write here. So the 5, if I cancel here, you will get 44. So then by 2 it will be 22, it will be 66. So this will be 2, this will be 6. 6 by 2, what is the answer? 3 ohm. How many 132 ohm resistors we require? 3 132 ohm resistors we require for connecting this in parallel. A concave lens has focal length 20 centimeter. So we know that f is equal to minus 20 centimeter. I told for concave means focal length is minus. At what distance should an object be placed? So we do not know u, we have to find out. So that it forms an image V 15 centimeter away from the lens. It is concave lens, so V is minus 15 centimeter. So the same numbers we did just now. So it is a lens, so we can use the lens formula. 1 by f is equal to 1 by V minus 1 by u. So 1 by u is equal to 1 by V minus 1 by f. If you substitute 1 by minus 15 minus 1 by minus 20. So is equal to, what will be the LCM? 60 minus 4 plus 3 minus 1 by 60. Therefore u is equal to minus 60 centimeter. Now the question is, if the current I through a resistor is increased by 100%, assume that temperature is the same, the increase in power dissipated will be. So we know that power is equal to, we have different formula for power. Which are the formula? VI is the original formula, or we can write P is equal to I square R, or we can write P is equal to V square by R. But here we have only current and resistance, so we can use this formula P is equal to I square R. So in this case they are telling current is 100% increase. Suppose this is the I going through this, R resistance R, current I is going through this, and temperature remains the same. 100% of I means 100 upon 100 of I is increased, then already I is there. So this is 1. So I plus I, what will we get? 2I. So current has increased twice. Whereas resistance will not change. Why? Because there is no change in the temperature. Apply this 2I in this formula. So we will get P is equal to 2I the whole square R. So what will we get? 4I square R. Right. And what is the increase? Increase in the power dissipated. So what new power is 4I square R, whereas the initial one is I square R. So we will get 3I square R. So I square R is the original power. So new power P dash is equal to 3P. So how many percent increase? 3 times increase. So we can say that 300% increase is there. Suppose it is increasing 100%. If iron bar is introduced inside the current carrying solenoid, the magnetic field inside the solenoid, the answer will be increase. Why? Because already solenoid has a magnetic field inside. We are introducing a soft iron bar which is ferromagnetic. So the magnetic field will increase because of the effect of this iron. Study the table given below and state the medium in which light ray will travel fastest. So we know that velocity of light will be high in optically rarer medium. Whereas if it is becoming denser, the velocity will decrease. So here refractive index is the least for this. So this is the rarest and this is the dense. So which will go faster where it is rarer. So through medium A it will be traveling faster. Inside the house, connections to all the devices are made in parallel. Of course, we know that, each having independent switch and fuse. Thus, whenever some fault occurs in circuit of one particular device in one room, devices in other rooms do not suffer. That's the advantage of parallel connection. So here the figure shows 240 volt AC mains circuit to which a number of appliances are connected and switched on. You can see this is the voltage or potential difference available 240. To it there are connected a few appliances. Fan is connected, refrigerator is connected, and two 60-watt bulbs are also connected. Calculate the power supplied to the circuit. So power, we just have to add the total power in the circuit because they are all in parallel. So we can say that total P will be 1.2 kilowatt, but we have to transfer it into watt because rest all are given in watt. So we can multiply by 1000. So it will become 1200 watts plus 200 plus 120. So what is the total number? 1520 watts, or we can say that 1.52 kilowatt. Next, calculate the current through the refrigerator. So we know the power. Here the refrigerator is given. We know the power and we know the potential difference. So what is the equation? P is equal to VI. So to calculate the current through the refrigerator, we know that P is equal to VI. So power is given 200 is equal to 240 into I. Therefore I is equal to 200 divided by 240. .8 ampere of current is passing. The energy used by fan in 3 hours. So how will you calculate energy? Energy means power into time. So what is the power of the fan? The power of the fan is 1.2 kilowatt into how many hours? 3 hours. So we will get 3.6 kilowatt hour. If you are finding out in joules per second, it is 3.6 into 10 to the power of 6. So if you multiply, you will get 1.296 into 10 to the power of 7 joule per second. So the next question is the resistance of the filament of one lamp we have to find out. So to find out the resistance, we know according to Ohm's law, we know we want I and V. V is here. So how will I find out I? From P we can find out I. P is equal to VI. Therefore I is equal to P upon V. What is the power of the bulb? 60 watts. What is the voltage? 240 volt. So you know that this is 1 by 4. I is equal to 1 by 4, or you can say 0.25 ampere. Okay. Now using this we can find out R. Resistance is equal to V by I. So again 240 upon 0.25. So here if you calculate, so the resistance is 960 ohm. Define the term linear magnification with reference to spherical mirrors. Magnification is the ratio of size of the image to that of the size of the object. So that is magnification, we know height of the image by height of the object. Now if a concave mirror forms a real image 40 centimeters on the mirror, so V is equal to minus 40 centimeter. When the object is placed at a distance of 20 centimeter, U is equal to minus 20 centimeter. From its pole, find the focal length and magnification. Both we have to find out. So first we will use the mirror formula. 1 by V plus 1 by U is equal to 1 by F. So 1 by F is equal to 1 by minus 40 plus 1 by minus 20. So here if I take the LCM, it is 40 minus 1 plus minus 2. So minus 3 by 40. So F is equal to minus 40 by 3. So 13.3 3 3 you will get. Now we have to find out m also. We know magnification is equal to minus v by u for mirror. So here what is v? Minus 40 upon minus of minus 40, then u is equal to minus 20. This will go 2. So magnification is minus 2. So from this we know 2 stands for double the size, minus stands for real and inverted image. Again we are coming to a case based question. So here I have deleted the theory part of the question. Here they have given a chart showing the refractive index of different media. Write down the formula used to find out absolute refractive index of a medium. If you remember the first question we used that formula, n is equal to c by v, where n is the refractive index, c is the velocity of light in air or vacuum, and v is the velocity of light in the medium. Find out the speed of light in benzene. So benzene we have to find out. Benzene is given here. Okay. So n is equal to c by v we can use. Here n is equal to 1.5 is equal to 3 into 10 to the power of 8, which is the velocity of light in air by v. So v is equal to 3 into 10 to the power of 8 by 1.5. So we will get 2 into 10 to the power of 8 meter per second. Then find out the medium with the lowest refractive index and medium with the highest refractive index by using the data given above. Also mention the refractive index of the corresponding media. So the lowest is always air. It is near to vacuum, 1.0003, and the highest is diamond with the 2.42. Write two pairs of media which is optically denser than the other but massively rarer. So here the answer is water and kerosene. According to this, water is optically rarer than the kerosene. Here we are talking about the optical density, but actual mass density, if you see, water has more density than kerosene. How is the speed of light and refractive index of the medium related? We know that when the refractive index is high, then the speed of light is less, inversely proportional. A concave mirror is used for image formation for different positions of an object. What inferences with necessary calculations can be drawn about the following when an object is placed at a distance of 10 cm from the pole of a concave mirror of focal length 15 cm. Minus 15 because it is concave. Concave we use minus. Position of the image we have to find. You can use the mirror formula. 1 by f is equal to 1 by v minus 1 by plus 1 by u. Mirror formula is a plus. So 1 by v will be 1 by f minus 1 by u. If you substitute the value, is equal to 1 by minus 15 minus 1 by minus 10. It will be 1 by minus 15 plus 1 by 10 is equal to LCM. If you take, it is 30. Here minus 2 plus 3. So it is 1 by 30. V is equal to plus 30 centimeter. So we know that in the case of concave mirror, there is only one position where the image is forming on the other side of the mirror or behind the mirror, then only it becomes positive, that is between F and P. So now we are coming back to the question. Position of the image 30 centimeter behind the mirror. Size of the image will be enlarged. Nature of the image will be virtual and erect, because this is the only situation where the concave mirror is producing a virtual and erect image. State any 2 points to distinguish between AC and DC. AC means the alternating current and DC means the direct current. AC changes its direction, whereas the DC does not change its direction. AC can be transmitted without a loss for a long distance, but DC transmission is less efficient. AC usually comes in different frequencies that depends upon the country, like 50 Hz, 60 Hz, etc. Whereas DC, the frequency does not change. List 3 characteristic features: direction, frequency and a voltage of the electric current used in our homes. When we talk about direction, it changes periodically. Frequency that is available in our homes is 50 Hz in India, and voltage between live and neutral varies 220 volt in India. Why is it necessary to earth metallic electrical appliances? We know that if there is a flow of current through the metallic body of the gadget to protect us from getting electric shock, we are using earthing, a resistant wire with a less resistance, so that the excess current will flow through the earth wire to the under the soil where it is connected, so that we will be safe from electric shock. These details are given in my electricity chapter explanation. Please visit the video and you can make use of that. Draw a schematic diagram of a circuit consisting of a battery of 3 cells of 2 volt each. We know that 3 cells means 1, 2, 3, right? Positive, negative. And a combination of 3 resistors, 10 ohm, 20 ohm, 30 ohm, connected in parallel, plug key and an ammeter, all connected in series. We know that ammeter is connected always in series only. Use this circuit to find the value of the following: current through each resistor. I think we did the same problem already. One is equal to V by R1. V is constant. So, but here the potential difference is different. Only 6 volt is there. So we can say 6 by 10, that is 0.6. Second, I2 is equal to V by R2, that is 6 by 20, 0.3 ampere. Please write the unit without fail. I3 is equal to V by R3. What will you get? 6 by 30. Total current in the circuit, we just have to add. Current will be I is equal to I1 plus I2 plus I3. So what is the total current? 0.6 plus 0.3 plus 0.2. 1.1 ampere is the total current. And total effective resistance also we have to find out. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So here we know that Rp will be 1 by 10 plus 1 by 20 plus 1 by 30. LCM being 60, we will get 6 plus 3 plus 2, 11 by 60. Therefore Rp is equal to 60 by 11, 4, 5, ohm. Okay, this is how we have to draw the circuit. You have to show the arrow mark of the direction of current. Hope these questions are useful to you. If you want such videos in future, please let me know through the comment box, so that I will make more numerical based videos. And also whichever topics you want, please let me know through the comment box. And if you like, please give a thumbs up and share with your classmates also. Thank you for watching Biology My Passion.